Okay, so if we were to spin this around, we'd have something that would look like half of a football. Now, here's how we find the volume. Consider if I just built one tiny little rectangle. If I built one tiny little rectangle and I spun that one tiny little rectangle around the x-axis, what would it look like? It would look like a skinny little cylinder. Here's a skinny little cylinder. That's what it would look like. You'd have one line, spin it around the axis. You'd get a teeny tiny little cylinder. That one says amatic on it. How do you find the volume of a teeny tiny little cylinder?
It's a cylinder, so it's straight on the edges.
Yep.
Okay. We're not doing like a curved top.
Well, remember, no, we're not doing a curved top, because remember, when we build our rectangle, we choose either the left-hand side or the right-hand side, and we go up and we make it straight across on the top. And then we make more and more and more rectangles so that the error gets smaller and smaller. So how do you find the volume of a cylinder in general?
It's base, you're saying the base times height, so the base would be pi r squared and then multiplied by.
Excellent. To find the volume of a cylinder, you find the area of the circle, and then you multiply by how tall the cylinder is. Okay? So, again, think about we're taking this rectangle and we're spinning it around. So the volume of that single rectangle would be pi times the radius squared times the height of the cylinder. The height happens to be the width of the rectangle that we started with. So how wide is that rectangle? How wide are rectangles in general? When we did our summation formulas for integrals, when we built our rectangles, how wide were our rectangles? They were delta x. So how wide is that rectangle? Depends on how many rectangles we're going to build. But in general, we would call it delta x.
This is making more sense. I was thinking around the y-axis for some reason.
Oh, we'll do it around the y-axis too in a few minutes here.
It's the same thing.
Yeah, I was just trying to figure out why you were talking about such a
Yep.
short cylinder.
And then, what's the radius? The radius would be that length, wouldn't it? How long is that? Well, in general, it would be just the height of the function, wouldn't it be? If I built my rectangle over here, it would be a little taller. If I built my rectangle over here, it would be a little shorter. So isn't that just the height of the function squared? In this case, our function is very specifically 4 minus x squared, but I could just write f of x. So that would give me the volume for one skinny little rectangle spun around the axis. Now how do I create an infinite number of rectangles and spin them all around the axes and add up all the volumes together? It has to do with integrals. That was our idea, wasn't it? How did we take the limit as n goes to infinity of the sum from I equals 1 to n? We decided that was the same as an integral. So, our formula for volume is going to be pi times the integral from a to b of f of x squared dx. And really all this is the formula for volume of a cylinder. This is pi times the radius squared times the height. And then this symbol just means build an infinite number of little rectangles and add them all up. That's all it is. So if I want to find the volume of this half football shaped thing, my answer would be volume is pi times the integral from 0 to 2 of 4 minus x squared dx. How would you evaluate that integral? FOIL it out, okay? So that's going to be pi, the integral from 0 to 2 of 16 minus 8x squared plus x to the fourth dx. Take the antiderivative, that's pi times 16x minus 8/3 x cubed plus 1/5 x to the fifth.
It sounds better to switch it around now, but yeah, to put it in descending order.
Oh, I probably should have. I probably should have put it in descending order. But I didn't. Probably would have been a good idea. It's not going to affect our answer in the end, though, is it? It would have looked better. All right, but now that we plug numbers in, that'll take care of itself. So we're going to have pi times, I plug in 2. 16 times 2 is 32. Minus 2 cubed is 8. 8 times 8 is 64, so that's 64 over 3. Plus, plug in 2. 2 to the fifth is 32, so that's 32 over 5. I think I'll grab my calculator now. 32 minus 64 over 3 plus 32 over 5. My calculator says that 256 over 15 pi. That would be the volume. So that would be in cubic units, whatever our units are.
Now we have to, now that we're working with both areas and volume, we probably should put something behind this? I don't know.
Wouldn't be a bad idea to put units cubed at the end. Typically you don't. Typically you wrote volume at the beginning,
Yeah.
so people recognize this point.
Yeah, because in some cases there's something we might have to use an area over here and volume over here.
True. So we would write area equals and then volume equals.
Why didn't you factor in 0?
Excellent question. I ignored the 0 altogether. How come? When I plug in 0, I get 0 minus 0 plus 0. I should have said that. I forgot. But yes, I do need to plug in the 0. It turns out to be 0. I was thinking that in my head and didn't say it. Good question. All right, let's pick another function. Anybody got a good function?
9x cubed minus 6x squared minus 2x.
2x plus 3?
Minus 2x plus 3.
F of x equals 2x plus 3.
That's the end of it.
Okay, that was the end of my wonderful function. Okay.
All right, so 2x plus 3
That's a lot.
is a line. Looks something like that. Okay? We need bounds of integration this time, so how far left and how far right do you want to go? Well, the problem with going 3 both ways, we can do that, but I think this point right here is negative 1.5. So if we go 3 both ways, we're going to have 2 separate chunks, aren't we? So how about we just start right here. This is from negative 1.5, and then we'll end at 3. So we're going to take basically this triangle, and we're going to spin it around the x-axis.
Would that just be cone?
I do believe it would be a cone.
Does that make anything easier?
It could make things easier because we do know we might know a formula for volume of a cone. I don't happen to remember what it is right off the top of my head.
It has to be 1/3.
Something with a 1/3. All right, we'll just figure it out the calculus way.
Can't you, I mean, because now it's too easy with the radius to find the area of the circle and then you can actually find it.
Well, we'll just do it the calculus way. Again, think of what happens when you take one tiny little strip. If you take one tiny little strip and spin it around, you get a little cylinder. So we're going to have pi, the integral from minus 1.5 to 3 of the height of the strip. How long is this strip? It's f of x. It's 2x plus 3. And then we have to square it because it's radius squared. Dx. Okay. So very similar to the last problem. we got to FOIL it out, work through, see what we get. This is pi, the integral from negative 1.5 to 3 of 4x squared plus 12x plus 9 dx. Find my antiderivative. That's pi times 4/3 x cubed plus 6x squared plus 9x. And I got to plug in 3 and plug in negative 1.5. Pi times, let's see, when I plug in 3 cubed is 27, but then 27 divided by 3 is 9, and then 9 times 4, that's going to be 36. Plus, plug in 3 squared is 9, 9 times 6 is 54. Plus, 9 times 3 is 27. So that's what I get when I plug in 3. And unfortunately, this time I don't get to just have the number 0. This time I really do need to plug in minus 1.5. So that's going to be minus pi times 4/3 times negative 1.5 cubed plus 6 times 1.5 squared plus 9 times 1.5, negative 1.5 and negative 1.5. I grab my calculator. 36 plus 54 plus 27 minus 4/3 times negative 1.5 cubed plus 6 times negative 1.5 squared plus 9 times negative 1.5. I get 121.5 pi. Yes, we will always have a value times pi because pi is always right there in the formula. So you're always going to have a pi in your answer. Always, always, always. James.
Isn't it true that it's like I know it's with the circle that pi, 2 pi r is the circumference, correct? Or is that
2 pi r is circumference of a circle.
So then it goes the circumference, and then it does the area, and then it does the volume, right? If we go down the derivatives.
Yes.
Actually, down the integral.
Antiderivatives. Well, it depends on which end you start on. That is correct.
But is that the volume of the sphere?
Yes.
It is. Okay. Or is that true for everything?
No.
What is the volume of the cone? We tried to check it, but
Because I was just going to take 1/2 base times height and take the antiderivative.
I don't remember the formula for volume of a cone, but it's something like,
I thought it was like 1/3 times the volume of the cylinder, but I'm not sure.
I think it's 1/3 times pi times the radius squared times the height.
Which would be 1/3 times.
Yeah, I think so. All right, so how are these problems going to get harder? Those didn't seem too bad.
What was the x and the eta?
121.5 times pi.
Is the one that's really weird shaped, or when you try to find, like, when you rotate it, it's not like a perfect image?
It's always going to be.
No, it's always going to be a nice symmetrical shape when you rotate it. Okay, we could have ones that go on the negative side of the axis and the positive side of the axis. That wouldn't be a big deal. You just have to set up 2 integrals. One for the positive side, one for the negative side. Not so bad. A little bit harder, but not so bad. Well, here's how they're going to get harder. What if I give you 2 functions? And it's kind of like, I might ask you, find the area bounded by those 2 functions. Or I might say, find the volume by taking the area bounded by those functions and revolving them around the x-axis. All right, so first off, what do these 2 functions look like? One is a line, one is a parabola. All right, so I think y equals x squared looks like this. And then I think y equals x looks like so. And they cross right there, and they cross right there. What are those points where they cross?
0, 0, 1, 1.
0, 0, and 1, 1. So what I'm asking you to do is take this little area right here, spin it around the x-axis, and tell me what the volume is. No, not a shell.
A bowl.
Not a ball. Well, let's look on the computer. See. Do I always have to spin around the x-axis? No, we could spin around other things, and we'll do that in a few minutes too. What's that do? Makes it harder. That's what it does. Spinning around the x-axis is easy in comparison. All right, what's the first thing we probably should do? Probably draw a graph. We need to know which one's the big one, which one's the small one. We need to see our region. All right, so 2, 4 minus x squared over 4. Graph. Okay, so here's our region. Our region is over the line, but under the parabola. So it's this little area right here in the middle. That's our region. What else do we need to know?
Wait, how do we know it's that way?
Because if it were over here, if it were the line in the parabola, that would be unbounded. It would be an infinite size. That would be no good. So it's got to be this little top of the mountain here, I guess. Don't know what else to call it. What else do we need to know? The interval. We need to know where they intersect, all right? Calculate the intersect. (2.828427.1). Uh-oh. Got a problem. What's the problem?
Crappy number.
It's a crappy number. What do I do when I have a crappy number?
You could find it with, I don't know.
Give up and call it a day.
Because
No.
you don't want to round it, because that would be easy.
Fractionize it.
I don't want to round it because that's going to give me error. Correct.
You need to find the exact.
This is a case where I think I need to find the exact place where they cross. I think that this is some irrational number. I don't think it's even a fraction if I try to do it a fraction.
So plug in
This right
2
here.
for y and solve for x.
Right, so what I'm going to do is I'm just going to take these two equations and I'm going to set them equal to each other. Plug in 2 for y. So I think I need to solve 2 equals 4 minus x squared over 4. Unfortunately, you can't always solve with the calculator. When the answers are not nice, the calculator is just going to give you a decimal approximation. How would you solve that equation?
2 no, multiply with the 4 over, multiply that 4.
Move this 4 over or that 4 over? The one on bottom?
First 4.
This one? So subtract 4 on both sides? All right, so negative 2 equals negative x squared over 4.
Now you need to hit the 4 over.
In fact, I'm going to multiply by negative 4.
Yeah.
Get rid of the minus signs at the same time. 8 equals x squared. So x is plus and minus square root of 8 is where they cross, correct? They cross square root of 8 here and negative square root of 8 there. Okay, so now I'm ready to find my answer. My answer is the volume is pi times the integral. If I need the big function, which one was the big function? The parabola. So that's 4 minus x squared over 4, all squared, minus, what was the little function? 2 squared dx. And what am I going to use for my bounds of integration? Negative square root of 8 and positive square root of 8 would work perfectly, but I think there's an easier way. How about if we just went from 0 to square root of 8? And then what would we have to do? Double it. And why was that slightly easier? I really enjoy plugging in 0. I don't enjoy plugging in negative square root of 8 so much. So that's a trick you want to look for. Anytime you have a symmetry like that, if you can plug in the number 0, that's a good thing. So I would double my answer and go from 0 to the square root of 8. It's going to save me a little bit of work. Not a ton, but a little. Should we work that one out? You're okay? You're not going to get nice answers, are you? No, you're not going to get nice answers for that one. That's okay. Questions on that one? Yes?
I'm sorry, why is there a 2 in front of pi?
Because I really should go, when I do my bounds of integration, I really should go negative square root of 8 to positive square root of 8. But I decided to go from 0 to square root of 8 and double it, because I like to plug in the number 0. Because 0 is usually very easy to plug in. Usually when you plug in 0, you get 0 everywhere. Not always, but usually. So that's why I doubled it.
I don't think you did 0 there. It's going to be a 4.
No, but when you find the antiderivative, you're going to get 4x. Right? So we would need to FOIL this out, combine our like terms, and then find the antiderivative. And this 4, when we find the antiderivative, would turn into a 4x. So when I plug in 0, I did think I would get 0. Yes?
So what would be like a real-world application of volume, or determining volume?
So what would be a real-world application of finding a volume? When might you want to know volume of something?
Construction, you have to fill it.
What's that?
You have to fill it with something.
You have to fill it with something. For example, my water bottle. Notice you could think of the water bottle, if you turn it on its side, you've got a function here, and then it's spun around an axis. So anything that's kind of circular, cylindrical,
But has a point at it.
right. And it has little ridges in the middle too to make it easier to hold. But how do you design that to make the volume to be 20 fluid ounces? Difficult. So you have to figure out the volume of it. So you got to build the shape so that when you spin it around, you get the volume to be the right size.
And in that situation, you wouldn't use the washing method, right?
On this situation with this water bottle, I think I could use the disc method.
Yeah.
Because I think I could split it right along its axis and have one solid shape. I don't have a big hole in the middle. Other questions?
Wait, but actually, since there's ridges, actually.
I think there's ridges on the inside too. I think it's all one molded piece. All right, so I just alluded to it a minute ago. I don't always need to spin around the x-axis, do I? I could spin around something else.
Or can't you spin it around the line going somewhere else?
Yes, in fact, that's what we're going to do next. So let's go back to a fairly easy function, y equals 4 minus x squared, from 0 to 2. So we've got this parabola, half of a parabola.
You want it around y equals x?
I just want to spin it around this line. This line happens to be y equals negative 3. So instead of spinning it around the axis this time, I'm going to spin it around y equals negative 3. So again, consider my general little strip here.
Well, that's working because it's parallel to the x-axis, right?
Correct. In this class, we will only use lines that are parallel to the x-axis or parallel to the y-axis.
Is there a way to do it or it's not?
There is a way to do it with a slanted line.
It's really annoying.
What you do is you do something called a translation of axis. So what you do is you translate the whole axis so that your slant line is rotated and it's now a horizontal line or a vertical line. And then you have to translate your functions also. We don't do that in this class, but there is a way to do it.
Is that like Calc 3?
No, you don't do that in Calc 3 either.
Yeah. You just have
You would do it in more of a descriptive geometry course. Yep. Okay, so here's the deal. When I take this strip and spin it around y equals negative 3, am I going to have one solid object? Am I going to have one solid disk? Or am I going to have a washer? Why am I going to have a washer? Because I have a gap right there. So that gap is going to cause a hole in the middle of my cylinder. So I'm going to have a washer.
And then the gap is going to be a cylinder.
The gap is also going to be a cylinder. That's true.
An exact cylinder.
An exact cylinder. So I think what I need to do, it's very similar to the problems we did before where we had a washer. So what we need to do is we need to find the volume from here all the way down to where we're spinning. And then we need to cut out that part that we don't want. All right? So our answer is going to be volume is pi times the integral from 0 to 2. How long is that strip right there? How long is it from the top of that curve all the way down to where we're spinning? Well, this distance right here is 4 minus x squared. Plus 3 more, isn't it? It's 3 more units. The height within the graph is 4 minus x squared. And then we need 3 more. So how much is 4 minus x squared plus 3? 7 minus x squared. So that's going to be 7 minus x squared minus, now I need to cut off this distance. I don't want that much. How long is that? That's just 3 squared dx. Questions on that?
Why is this so confusing to me when I took calculus the first time?
I don't know. Everything's easier the second time. All right, again, we would have to FOIL this out, combine our like terms, find the antiderivative, plug all your numbers in. From there, it's grunt work.
Where's the width come in again?
dx.
Yeah.
dx is always the width of your cylinder. So this is the height of the big cylinder times the width minus the height of the little cylinder times the width. Okay, now let's take that same exact graph, y equals x4 minus x squared. Y equals 4 minus x squared. From 0 to 2 still, so it's the exact same region. But this time, I want you to spin it around y equals 4. Wouldn't it be 0? No. So what I'm asking is take this shape.
Now you're cutting out what's on the outside.
And I want you to spin it that way around that thing.
So you're cutting out what would be on the outside if it was from around the x-axis, right?
Correct. So what I'm really doing is, you could think of it as being one big box, I suppose. We're cutting out this part in the middle, aren't we? That part's not going to be part of our volume. All right, so what do we do? Well, again, think of a typical little rectangle inside your graph. There's a typical little rectangle. When I take that typical little rectangle and I spin it around y equals 4, am I going to have a solid cylinder or am I going to have a washer? How do you know you're going to have a washer? Because there's a gap. There's a space. Anytime your little line does not exactly touch your axis of revolution, you're going to have a washer. You're going to have a gap. All right. Go ahead.
Will we ever do one where the parallel line goes through it?
No,
But
we won't do that.
what would that mean? Isn't it split into several?
That would make a difference on where the parallel line went through. It would cause a lot of complications, so we will never do that.
Does this work with sensing rule we have to go over with
Yes, you could use Simpson's rule, trapezoidal rule to approximate. If you ended up with an integral where you couldn't actually find the value, then you could use Simpson's rule or the trapezoidal rule to approximate your answer. Absolutely.
What is a trapezoid spun around its axis?
Well, it would look like a cylinder, except the edge wouldn't be perpendicular to the radius. It would be slanted slightly. So instead of this being straight, this would be slanted on the edge. We're not going to do that, though. We'll actually evaluate these directly. But you could use those rules to approximate if you had to. Absolutely. All right, so this time our volume is going to be pi times the integral from 0 to 2. All right, so now we need the big one minus the small one. This time, what's the big one? How much?
Everything.
That's right. The big one would be make your strip as long as you possibly can. That would be right there the biggest strip we could make from our region to our line of revolution. How long is that strip? 4. So that's going to be 4 squared. Minus, we need to cut out that little bit right there. How long is that little bit right there?
4 squared, 4 minus x squared.
That's length right there is the top, which is 4, minus the bottom, 4 minus x squared. It's 4 minus f of x. That's correct. So 4 minus x squared, that's just x squared, isn't it? So this would be x squared, squared,
Oh, wait, no, yeah.
dx. So you would have pi, the integral from 0 to 2.
It would be. Oh, why?
If I distribute the minus sign through,
Okay.
the reality is even if it were minus x squared, because I'm squaring it, the square would get rid of the minus anyway. So even if it were minus x squared and I made a mistake and dropped my negative sign, I'd still get the right answer. I'd get lucky on that one. So you can see? Sure. There you go. Questions on that one?
And then you just do the antiderivative.
You do the antiderivative, so it's 16x minus 1/5 x to the 5th.
And then
Plug in 2, plug in 0. When you plug in 0, it's easy. You get 0.
alright.
Yep. When it comes time to take a test, generally what I ask you to do on the test is simply set up the problems. So generally on the test, I tell you, you can stop right there. Just because evaluating these isn't difficult, but it is time consuming to plug the numbers in.
Depending on the problem, it can be really.
Depending on the problem, it can be pretty ugly. Yeah. So generally the directions on the test are going to be set up the integral needed to find the volume.
So you don't want us to make it like 16 minus x to the 4th, you're going to just leave it at 4 squared?
Oh, if you were to write it as 16 minus x to the 4th, that'd be okay. What I don't want you to do is find the antiderivative and plug the numbers in and give me the real answer.
I presume you're always going to get someone that tries to go the full way with it.
Well, some people will. Sure.
I don't know. I mean, sometimes, like, that's what my dad just told me. He teaches history. But when you ask someone to give a partial thing, like, just write an outline. Don't write an essay. There's always going to be someone that writes an essay.
Yeah, there's almost always somebody that doesn't follow directions. I would agree with that.
And so that means they do too much.
Right. Other questions? All right, let's
How
do.
much would you take off if they actually found it?
As long as I did it correctly, I wouldn't take off anything. But if they made a mistake, then I'd have to take off points for the mistakes.
So they set the problem up correctly, but then made a mistake later on.
Sure, I'd still take points off. All right, let's do one more. How about we'll do one with two functions again. How about go back to y equals x squared, y equals x. And what line do you want to spin it around? Anybody got a favorite line?
No.
Other than the axis, because we already did the axis. Okay, it's got to be a horizontal line.
How about
Still not a horizontal line.
How about
How about y equals 3? Y equals 3 would be a horizontal line. That's an excellent question. So far, you might notice every problem we've done, I've used a horizontal line. Can we spin around vertical lines? Yes, we can. Come back tomorrow, and we will spin around vertical lines and see what happens. When you spin around vertical lines, you have to use dy. Correct. Because you're building horizontally, which means you have your thickness as dy. All right, so
we're already looking at area between the y-axis, so it would just be the same sort of thing.
correct.
I mean, the same relationship between area and volume that we have on the x-axis.
Yep, it's going to be the same relationship.
We haven't defined
Perimeter? Well, you have a three-dimensional object, so it wouldn't be perimeter, it would be surface area. So yes, we will talk about surface area in the future. That comes up at the end of chapter 7. If you have a three-dimensional object like this water bottle, what's the area of the plastic that it took to build it? We'll talk about that. All right, so we're spinning around y equals 3, which is way up here.
That would be
Should have been higher, but I was running out of room.
surface
Scale's
area
not very good.
of an object could be applied when
Well, surface area is very important. How much plastic does it take to build this object? I mean, that's something you're very concerned about because the least amount of plastic you can use, the lower your cost is going to be.
Because we're always in science, we're always talking about surface area to volume ratio, which is why cells are so small.
Correct.
Or if you want to find the surface area of something that looks sort of strange.
Yep. All right, so
In science.
here's our little strip inside our region. Looks just like this. When I spin that little strip around the line, y equals 3, am I going to have a solid cylinder or am I going to have a washer? In fact, I'm going to have a lot of washer, aren't I? I'm going to have a big gap. Just a little bit of solid material.
I have a question.
Yes?
So if you wanted to use this stuff to find the area of something that's outside of the graph that you just have just a solid object that you're looking at, so to do that you just figure out where the axis is.
Correct.
Just insert it mentally into an axis.
Yep. All right, so our volume is going to be pi times the integral from 0 to 1. All right, I need the big strip. How long is the big strip? Not 3. Because 3 would go all the way from here, all the way down to the axis. I want to go from here to where? I want to go 3 to there, don't I? So how far is that? That's 3 minus x squared. Very good. So that the big one is 3 minus x squared, minus, and then the amount we need to cut out from there to there. So how long is that? That one's 3 minus x, whole thing squared. All right, and then once again, if you actually had to find the answer for this, had to find the value, you would FOIL this out, you would FOIL that out, you would combine all your like terms, you would find your antiderivative, you would plug your numbers in, and you would get the answer. Again, on the quiz, on the test, the directions will be stop right there. When's our next quiz? Let's shoot for Friday.
When's our next test?
When's your next test? After Friday.